Hi, everyone. So, this next section of similarity is called parts of similar triangles. If you remember from chapter 5, which was last chapter, we learned about medians, altitudes, and bisectors. And so, what this section is about is if you have similar triangles and the triangles have those pieces, those segments in them, those segments are proportional to the sides. That's pretty much what it is. So it's just more writing proportions, solving proportions. It's pretty easy. So to fill in this box here, this is 3 theorems in one. I just combined them to make it less writing. And so it says when two triangles are similar, corresponding medians, angle bisectors, and altitudes are proportional to the corresponding sides. So there's the first theorem. So I have a few examples. Now I will say a lot of the examples for this section end up being decimals. I'm not really sure why. It doesn't have anything to do with the theorem. I just think that for this particular section, the book that I got the problems from, it ended up being a lot of decimals. So don't worry if you're getting a lot of decimals. Okay, so let's see this first example. So this is an angle bisector, so is this. So if these triangles are similar, then the angle bisectors in the sides are proportional. So when you set up your proportion, you can do it several different ways. You could go side to side equals angle bisector to angle bisector. Like you could do x over 24 equals 8 over 10. That's probably what I would do. But you could also do like 8 over 10. I mean, x over, oh boy, x over 8 equals 24 over 10. There's a lot of different ways. So we're going to cross multiply here. So we're going to have 10x equals 192. So then if you divide by 10, we get 19.2. So there's the first one. Next, this is an altitude. Even though it's on the outside of the triangle, it's still considered to be an altitude. And that's an altitude. And then you have side, side, or you could use this side too. It doesn't matter. So you could do x to 7 equals 10 to 8 and cross multiply. So 8x equals 70. And then 70 divided by 8 is going to be 8.75. Okay, next one. This is a median. So is this. So we can go x to 25 equals 26 to 39. So that's going to be 39x equals whatever 25 times 26 is, which is 650. And then divide by 39. So this one's going to be 16 and 2/3 or 16.6 repeating, or 16.7, whatever you want to write. Okay, so on to the next page. There's another theorem. This one is specifically with an angle bisector, and it's with one triangle, not two. So if you have an angle bisector in one triangle, it talks about what happens. So ready? An angle bisector in a triangle separates the opposite side into two segments that have the same ratio as the other two sides. So basically they're proportional. So there's 1, 2, 3, 4 pieces that are proportional. So you can set this up a lot of different ways. I usually go like side to bottom, but I mean, it doesn't matter. You could go 15 to x equals 30 to 20. Or you could do another option. You could go like bottom to bottom, side to side. You could go x to 20 equals 15 to 30. That would work too. Doesn't matter. We could keep going, but I'm not going to. So let's do this one. So that's going to be 30x equals 300. X equals 10. And so there's that one. Okay, sometimes you have to subtract, just like how we've been doing. So this 160 is the whole thing. That whole bottom is not proportional to anything. It's these two little pieces. So if we subtract 100 from 160, this is 60. So now I can do R to 60 equals 110 to 100. So that's going to be 100R equals 6,600. And then divided by 100 is going to be 66. So there's that one. Last one. We have these two pieces are proportional to these two pieces. So I'm going to do x over x plus 7 equals 11 over 17. Cross multiply. I'm going to continue it over here. Actually, let's move this down. Never mind. Oh dear. Okay, here we go. Oh boy. All right, 17x. Anyone catch that? Equals 11x plus 77. So I'm going to subtract 11x. So it's going to be 6x equals 77. And now divide 77 by 6. And it's 12.83. And that's it. So that's the last example. As you can see, nothing too different from what we've been doing all this time, just more setting up proportions and solving them. Please try the problems. And if you have any questions, please reach out and let me know. All right. Have a great day.